All right. Good evening. I guess seventh grade because I think every math team now has the link. So can't say seven green anymore. So seven red, seven blue. Welcome if you're here, and seven green. Of course, it's always good to see you guys. Sorry if I'm a few seconds delayed. My hair and makeup lady took a long time. Hair was looking all right though. So the production values dropped a little bit. I'm back to the easel, courtesy of my 4-year-old Kylie and my 1-year-old Mason. Although he'll be 2 in 3 days. Um, so today I went back to the easel because I know I've been doing the drawing app on the computer, and I decided that there's so many steps for writing that I'd rather draw decent 3D figures and write out the equations as opposed to have really nice looking figures and have really sloppy equations because the work that I'm going to do here is the most important part. So let's see. I told you the fourth dimension is real, live, and yeah. Well, hold on, take it easy. Okay, like I said, we're going to be focusing on two-dimensional and three-dimensional shapes. Fourth dimension involves space-time continuum theories. I talked about alternate timelines because if you're in the future, you go back to the past, you change something. Now you've created a parallel timeline. So we're not going to talk about parallel timelines today. So we're not going to get into the fourth dimension. All right. So some of you need to watch Back to the Future though. But anyway, um, let's see. I see we're talking about Infinity War. Yes, it's very exciting that Avengers Endgame comes out technically tomorrow, but officially Friday. So as much as I want to talk about that, we got to get down to work here. So I'm going to be going over the items on the study guide. And again, if you're on 7 red or 7 blue, everything I'm going to talk about today is still applicable to what you're doing. And of course, I might do things a little differently than your teacher. If you have Mrs. Steffens or Miss Fitzgerald, they might do things slightly differently. So this is kind of my take on how I teach these things. So it might be a little different, and I hopefully don't make any errors or anything. But I'm going to go through volume of prisms, volume of pyramids. I'm going to talk about surface area for both, and we're going to talk about composite figures as well. And composite figures are when you have more than one solid put together. So the volume for that's pretty easy because you just find the volume of both shapes and add them together. But surface area can be a little tricky because when you combine two shapes, it's like putting a roof on a house, right? When you have a roof on a house, you might have like a shape here. Okay, it might be like I said, a 3-dimensional shape. But with a composite figure, so you might have like a pyramid on top of a cube. But like the roof of a house, you can only see the exterior of the house. You can't see the interior. So composite figures, we can't count when they share sides like this. So the base of the pyramid and the top of the cube, they share a side that we can't see from the outside. So we can't count that in the surface area equation. So again, this is composite figures, and we're going to get to those towards the end of the video. So if that's something that has been confusing you in class, that's something that we're definitely going to cover today. So we're going to take it easy. I'm going to go in order for the most part. There's a few problems I'm going to skip because they're a bit repetitive. So I'm going to go over square pyramid prisms, and then I'm going to do one of the composite figures. And those things that I go over are going to be applicable to other shapes that you'll see as well. So, if I do one square pyramid and there's another square pyramid, the only thing that's different is the numbers. So just keep that in mind. All of it's going to be similar. I'm just going to try to do one of each shape to keep it simple. So anyway, so we're already almost 4 minutes in, so let's go ahead and get started. So I'm looking at the first problem here, okay, and it says it's a rectangular pyramid, okay, but the issue is it doesn't give us all the sides. It gives us one side of the base. So I'm going to try to draw my best pyramid here, okay, and I'm going to draw just the dimensions that we can see for starters, and we're going to talk about those, and then I'll draw the dotted lines inside in a different color, maybe in green, so that we know they're there. We're going to talk about them being there, but we're gonna, I don't want to confuse you just yet. So here's a pyramid, okay, and it says it's a rectangular pyramid, but they only give us this one edge here as 3. So I know they're calling it a rectangular pyramid, but because we don't have this measurement, we're actually gonna consider it a square pyramid, okay? So we're gonna call it a square pyramid. So I'll just write that down. Square pyramid. And on your test, that'll be specified, okay? Pyramid, okay. I didn't become a math teacher, know how to spell. Hopefully I spelled it correctly. So so this edge is 3, okay? And then the other measurements I'm given a slant height. I'm going to put it in blue because it is on the outside, okay? I'm given a slant height. and the slant height is 4.8. Okay, so this is, and they give you the little right angle here because they want to show you that this is actually the height of the triangle on the outside here. Okay, so that's not what we're going to use for volume. We're going to use that for surface area. So we're going to come back to that in a minute. Okay, but the one measurement that we want to work with today, and I'm going to draw the inside of the pyramid now. Okay, so that's in green. We're doing X-ray vision here. All right, there we go. Okay, so there's the inside of the pyramid. Hopefully you can see that just faintly enough on the computer. But the pyramid itself, the whole pyramid has a height, okay? And that's going to be shown right down the middle here. I'm going to do that in purple so it stands out. But it starts at the middle of the base, and it goes all the way up to the peak of the pyramid, okay? And this is the pyramid height. So this is the entire 3D shape's height, okay? And they say it's got like a little right angle there, okay? So this purple measurement here, we're going to say this is 4.6, okay? How are we doing so far? You can't answer me. So I've got that drawn up. I got to make sure I have a calculator handy because you're going to want a calculator on this test. And I know a lot of people rely on the Chromebook calculator, but you won't have that available to you during a test. So a calculator was required on your supply list. So make sure that you have that, okay? So I've got all the measurements that were given to me, I think. Yeah, I should. Okay. So now what we're gonna do is we're gonna find the volume of the pyramid first. Okay, so we're gonna use our volume of a pyramid formula. Okay, and those formulas will be given to you. So I gotta sink down a little bit. I'm sitting on a bench. It's really uncomfortable. My production value has dropped a little bit. See, so you gotta bear with me. Hold on. Okay, chill out, people. All right. Sorry. All right, dog's going crazy. All right, so again, it's a pyramid. Okay, so I'm going to do my volume of a pyramid formula. Bailey. Okay, so our formula is 1/3 times base times height. Okay, and in class I talked about why the formula includes 1/3, and that's because the base of the pyramid, if I were to make a prism out of the base of this pyramid, the pyramid would actually be 1/3 of the volume of a prism with the same base. So that's why they include the 1/3, which I've talked about quite a bit. And okay, I see some comments there. See some good. My dad says hi. Hello, Mr. Van Diglin. So the next part is I've got the formula I need, but here's where a lot of people get confused. And I'm gonna go slow on this first one, but I'm gonna speed the process up after we've talked about this. And it's about this capital B. Okay, and here's how I interpret that, or here's how I explain it. The pyramid formula, prism formula, they both include this capital B for base. Okay, and this means the area of the base. And if you've been keeping up on your math data, you would know this. Okay, that this is talking about the area of the base. So it's a capital B because we're actually going to replace that with a formula depending on what shape the base is. Okay, and so we have a square pyramid, which means the base is a square. Okay, so that means that the capital B is going to be replaced with the area of a square formula because we want the area of the base, and the base is a square. So we need the area of a square formula to go into this. So we're going to go volume equals. Okay, I'm going to keep everything else. So 1/3 times, and again, it's a square, so we know that it's length times width, okay, which it's a square, so length and width are the same. So we can say that it's length. I'll use the W because it's easier to see. We could say width squared. We can say side squared if that's easier. I know Matthew refers to that. So we could say side squared, okay? So for a square, all right, it's one side times itself, which means it's one side squared, okay? Still times the height of the pyramid. All right. So now we took the capital B, we turned it into the formula for the area of the square because that's our base. So area of the base, it's a square. So area of a square formula. Okay. I know that part gets confusing. All right. So now we have the actual formula. So now we can start plugging numbers in. All right. So I'm going to change colors here. I'm going to go back to blue. So volume equals 1/3, okay, times 3 squared. And the height of the pyramid, it's the inside height. Remember, the height of the pyramid is the inside height here that I put in purple, and that's 4.6. All right. So now we have all our numbers. So now all we have to do is solve. Okay. And right away, I know that 1/3 times 9 times 4.6 because I can do that 3 squared. I know 3 times 3 is 9. Okay. So what I would put in the calculator, okay, is you can do one of two things. So I'm going to show it on here, and we can talk about what they mean. So there's two ways to put this in the calculator, okay? You can do parentheses, 1 divided by 3 times 9 times 4.6, and that will get you your volume. Okay. Another way you can do this, okay, and they're both the same, is you can do 9 times 4.6 divided by 3. And that's because when I'm multiplying by 1/3, what I'm really doing is dividing by 3. I'm finding 1/3 of this. So dividing it by 3 gives me the same result. So whichever one works for you, but they both actually give you the same answer. All right. So if I take 9 and I times it by 4.6, and I'm using my calculator because I'm allowed to do that. Okay. And I divide it by 3, I end up getting a volume of 13.8. Okay, so that's my answer for number 1. What you can come here, Kylie. What's wrong? Well, come on over. You can come see. I'm borrowing your easel. Is that okay?
Yeah, that's
Here.
okay.
Okay, come say hi to everybody. Come over on the other side. Other side. Come on, I gotta teach math. Hurry up. Right here. Okay, say hi.
Hello.
You're supposed to be in bed, right?
Uh-huh.
Am I being too loud?
No.
Okay, go in bed. Goodbye. Say goodnight to everybody. Say goodnight.
Night.
All right, get out. Goodbye. Goodbye. All right, go. Go back to bed. You know, I'm a teacher most of the time, but I'm a full-time dad, so so that's part of the deal. But anyway, so that was a good time because now we're done with volume. So the volume of the pyramid is 13.8, and our units, I think it was what was it, feet? Let me look. Yeah, it was feet. Okay, so our units are feet. Okay, so we're going to say feet cubed, and that's because we're finding 3 dimensions with volume. We're finding the area of the base, which is 2 dimensions, times the height, which is the 3rd dimension. So 3 dimensions, we put a 3 over the unit, so it's cubed. Okay, rip that time, it's funny. All right, so this is just volume. All right, all I found is volume here. Okay, so if I want to find the surface area of this same pyramid, we have to approach things a little differently. Okay, so surface area and volume are 2 different things. Volume is how much space this object takes up, or in other words, how much space, how much can it hold? Okay, to bed. Thank you. Sorry. All right, so let's talk about surface area. Surface area looks a little different. Okay, so surface area is like I'm unfolding the way I explained it in class was volume is how much stuff fits in the box, and then surface area is how much cardboard makes up the box. Okay, so obviously this is a pyramid, but the same concept applies. Let's say I unfold the pyramid. Okay, and I know your teachers, whether it was me or any of the other 7th grade teachers, okay, we've talked about surface area being focused on 2-dimensional shapes. Okay, so I've unfolded this pyramid. Okay, because I have 1, 2. It's a square, so I have 4 triangles that fold up to make the pyramid. Okay, so this is what it would look like if I unfolded it. Okay, think of like a box and unfolding every flap of the box. That's kind of the same idea here. Okay, so what you'll notice is that I have 1, 2, 3, 4 triangles. So this is how I showed my students how to set it up. Was I said surface area for this shape equals 4 triangles. Okay, so I put a little triangle in parentheses because I'm going to do 4 times a triangle. And I'm going to add that to 1 square. Okay, so I need the area of 1 square. I need the area of 4 triangles. All right. So I like to set it up like this. I'm going to erase my volume equation here. I'll just put the V over here. I like to write it like this because I feel like this sets me up a little bit easier for solving the equation correctly, because I know I have to account for 4 triangles and 1 square. And the other thing is all of these triangles, they all have a base of 3. They all have a slant height of 4.8. So all these triangles are congruent, or they're the same. A star, it is nothing. I mean, I say it looks like a ninja star, but that's just me. What's the thing above the B for volume? The B for volume. I'm not sure. Oh, right here. I just put a little star there. My bad. Yeah, I was just talking about that. So, yeah, sorry. I see. I should have read the comments in order. I would have understood. Okay, so anyway, so I unfold the pyramid. Okay, I have 4 triangles, 1 square. 4 triangles, 1 square. So to find surface area is 2 dimensions. Okay, I just want to find the area of each object, and I want to add it together. Okay, so the surface area is going to be 4 triangles. Okay, and I'm finding the area of a triangle. All of the triangles are the same. They're all congruent. So what I'm doing here, since it's a triangle, I'm going to plug in the area of a triangle formula, which is 1/2 times the base of the triangle times the height of the triangle. Okay, so there's my triangle formula. And then I'm going to add this to the area of the square. So I don't have to multiply that, but area of a square formula is side squared, okay? So why is the volume cubed with the surface area squared? I'm actually going to talk about that, so hang on to that thought. I talked about volume being 3 dimensions. Surface area is 2 dimensions because all of these are flat. I'm only measuring the length and the width of them, okay? So triangle formula is 1/2 base times height, and area of a square is the side squared, okay, the side times itself. Now, what's nice about doing surface area after you've done volume is if you've done volume, you've already found the area of the base, okay? So we know from what we did here, we already did side squared, we did 3 squared, we know that the area of the base is 9. So I like to just plug that in right away. I know that the area of the base is 9. I'm just going to put it right there. I already did the work, okay? But we still have a little bit of work to do here, okay? So we have to, now that we have our formula, we have to plug in the values that represent the variables. So I need the base of the triangle and the height of the triangle, okay? So the base of the triangle is 3, okay? Because if this side is 3, so is this one in a square pyramid. So I have 3 for the base. So I'm going to replace the b with a 3. And then the height of the triangle, this is what I was telling my students today that seemed to be a little confusing. This is what we call the slant height, okay? This is because, again, the pyramid is on a slant. But what this is teaching us is that this is actually the height of the triangular side. This is the height of the triangle. And that's what we want for this equation for surface area. So what I was saying is surface area has an S, slant height has an S, okay? So that's how I mean, it's not much, but it's something to help you remember, I suppose. So I want the slant height, in this case, it's 4.8, okay? And again, I have 4 of these triangles, so I'm going to find the area of one triangle and times it by 4, because it doesn't make sense to find the area of all 4 triangles separately when they're all the same triangle. Just I have 4 of them. So now I have all my numbers plugged in, and now I can solve. I'm going to show the area of the triangle first. Okay, so I have 1/2. I like to do the 1/2 last because there's a reason for that. So I'm going to multiply 3 and 4.8. Okay, so 3 times 4.8. Okay, that's 14.4. Okay, and if you times it by half, you could times it by 0.5. Okay, times 0.5, and that equals 7.2. Okay, and again, it's a fraction, so you could times these two together and divide by 2. It's the same thing. However you see it. For me, I just like to. I'm in multiplication mode. So I multiply by 0.5. Same thing. So the area of one of these triangles is 7.2. Okay. So I'm going to erase these numbers now. Okay, so now I have the area of the triangles. Okay, they're all 7.2. Okay, so these are 7.2. And this is square feet because it's flat. These are 2-dimensional shapes, so it's going to be squared. Okay, but we're not there yet. Okay, so each of these triangles is 7.2. I have 4 of them. Okay, and I'm going to be adding this after I multiply these together. I'm going to be adding it to the area of the square, which we already know is 9. Okay, so multiply 7.2 by 4. Okay, we get 28.8. Okay, and if we add that to 9, sorry, I ripped a hole in my, oh, that's glue. I don't know what that is. But anyway, so 28.8 plus 9 is going to equal 37.8, and this is feet squared, because again, we're looking at 2 dimensions for surface area. So I went pretty slow with this problem. I know it seems like there's a lot, but keep in mind, I'm explaining each step. I'm explaining each variable. I've probably gone back and explained things twice. I'm color coordinating this. I mean, that's pretty awesome. So if you understand the concept of what you're doing, this will not take as long, okay? But I'm making it, I know I've made it seem like it takes 15 minutes. It doesn't take 15 minutes, okay? I took a lot of time to explain it. So I'm gonna see if I can catch up on some questions here. So does the study guide count for any points? Yes, it does. It's completion points. And again, you have to show your work. You have to show what you're putting in the calculator. Look how many steps I showed. If those steps aren't there, you can't get full credit on the study guide. No, they aren't. Oh, wait. Yeah, the study guide is completion. Thank you, Mr. Patel. Will you take points off if we don't have a label on the test? Yes, I will. If there's not a label, okay, and the label's given to you here, so make sure that's in your answer. But yeah, you have to have cubed and squared. Okay, so remember, surface area is squared. Okay, this is squared. Okay, volume is cubed. Okay, so that's something you just have to commit to memory. Maybe put it on a note card. And in my class tomorrow, you'll have an opportunity to make a note card if you're doing the rest of your work. And the formulas are given to you as far as I know, but I would just know them anyway. I would really try to commit them to memory, just because it's gonna make things go that much faster. It's gonna make it less likely that you'll make errors. Could you go over number 5? Yes, I'm actually I'm gonna go over some other problems. I'm gonna go over a prism, and then my pace is gonna pick up a little bit. And again, once the live stream is over, the video will save. So you can always go back, you can rewind, you can watch it again, you can pause it if you need to catch up on something. So so again, right now I know it's live, so don't feel like you missed it. You can always go back and watch it again. So what's squared, what's third, like which one? Volume is cubed, okay? Volume is cubed, surface area is squared, okay? So remember, volume is 3 dimensions. Area of the base, okay? The 2-dimensional base, right? The base is 2D, okay? And then we're timesing it by height, which is another dimension. So we have a 3D figure. Okay, surface area, I'm laying it flat, so I have a 2-dimensional figure. So 2 dimensions, it's squared. 3 dimensions, we put it to the third, which is cubed, okay? All right, so I'm going to move on, okay? And again, if you want to see this problem again, you can always go back and rewatch it. So I'm going to erase all of this, even though it's beautiful, okay? And instead of using Kylie's mermaid blanket, I got a paper towel this time. I thought that she'd appreciate that. So she was a little upset when she found all the dry erase marker all over her mermaid tail blanket. So, life of a dad. So that's the way it works. All right, so I'm going to move on to, I said to skip number 2 during my class. It's a triangular pyramid, and I didn't see one. I didn't see a need to go too into depth with that. But I am going to talk about this triangular prism. Okay, so this is number 3, and I know someone just asked about number 5, which I'll get to pretty quick, because the triangular prism is definitely something I want to talk about, because the way that this problem is set up shows a lot of common mistakes that students make. Okay, so I have a triangular prism. I'm going to draw it to the best of my artistic ability. Okay, actually, that's pretty good. Okay, so it says that this side is 6.5. Okay, so this side right here. It says that the height is 11. Oh my gosh, it's laying down. I called it height. It's weird, right? Talk about that. Okay, it gives me this line down the middle of the triangle, which I'm gonna draw in purple so it stands out a little bit. Okay, so they're saying that this is 6. Okay, they're saying, and this makes a right angle because it's the height of the triangle. They're saying this is 5. Okay, now they don't give us this dimension here. Okay, this side, but because it's not given to you, it will be on the test, but this is going to be 6.5 as well. Okay, so the edge of this triangle is 6.5. The edge of this rectangle is 6.5. Okay, the length is 11, or the height, if you will, and the base of this triangle is 5. Okay, so here's where a lot of students get confused. They say, well, the triangular prism is laying on this, so that's the base. This has to be the base. Okay, a prism is not defined by which way it's sitting. Okay, a prism is defined by the unique shape so in this case, it's a triangular prism. So I always tell my students, okay, step 1, identify the 3D solid. Okay, it's a triangular prism. Okay, so the name of the prism is going to tell you what the base is. So if it's a triangular prism, your base is a triangle, which means realistically, this shape should be stood up like this. Okay, and hopefully I can draw it well from this angle. Okay, so it should be stood up like this. Okay, where the height is 11. So I'm just reorienting the shape. Okay, so this would be 5. This would be 6.5. This would be 6.5. Okay, my height of my triangle. It looks good from this angle, but I'm not looking at it straight on, so I hope it looks okay. Okay, and the height is 6. Okay, so all the same measurements, but all I've done is I've stood the prism up. Okay, I skipped number 2 for now because I've already done a pyramid, so I'm going to come back to that one if I have time. And in my class, we skipped that one, so I'll go back to that one at the end if I have time. I'm going to try to keep the stream under an hour, but I think this one might go a little longer, and I have the time, so. But anyway, let's get back to the prism. Okay, so the volume, we're going to talk about volume over here, and we're going to talk about surface area over here. Okay, so I'm going to draw a little dividing line here. Okay, so we're going to talk about volume. Okay, I'll label it. We're going to talk about, I'll write it out. I'm not going to be lazy. Okay, and prisms are a little bit easier. And actually, believe it or not, I think that triangular prisms are the hardest. Okay, and I'll talk about why. But so once you stand the triangular prism up, now you see what the base is, you see what the height is. Okay, so we're talking about volume. Okay, and volume formula for any prism is volume equals the area of the base times height. Okay, so there's that capital B again. All right, and the reason it's a capital B is because I'm going to change that out for a formula based on whatever shape is the base. Okay, so it's a triangular prism, so I need the area of a triangle formula to replace this B. Okay, so this is going to become 1/2 times the base of the triangle times the height of the triangle. Okay, and then sometimes I like to capitalize this H. Okay, because when I capitalize this H, I'm talking about the height of the prism. Okay, the height here I'm talking about is the height of the triangle, which is the base. Okay, so I know that H tends to confuse my students. So for this demonstration, I'm going to capitalize the H to show that there's a difference. Okay, so again, volume equals the area of the base, which is a triangle. So I'm going to use the triangle formula. Okay, so volume equals 1/2 base of the triangle times the height of the triangle. Once I have that, I'm going to times it by the height of the prism, and I'll have my volume. Okay, so now that I know what values I need, now it's just a matter of looking at the picture and making sure I have the right ones. Okay, so volume equals 1/2. That's nice. Times the base of the triangle. So the base of the triangle is right here, which is 5. Times the height of the triangle. I'm going to change colors for this. The height of the triangle itself is 6. Okay, so that's where that 6 comes from. Nice blue mark on my arm now. Okay, and then I know the height of the prism because it's given to me. Now again, it's actually 11. I want the length of the rectangular side because that's what makes it a prism, is that its sides are rectangles. So again, if I stand the prism up, here's my base. The triangle is my base because it's a triangular prism, and the height is 11. Okay, so the height of the prism I'm going to put as 11. Okay, so now I've got all my numbers. Okay, so I'm going to solve the area of the triangle first. And I like to keep that separate. A lot of you might want to just throw that in a calculator, but you're going to see that if you do this and then times it by that in another step, it's actually going to help you on surface area. So keep that in mind, okay? And actually, because I'm all about different colors here, I'm gonna do surface area in purple because why not, right? So surface area is going to be in purple. Okay. So keep this formula in mind here, okay? So I'm going to solve this. So 5 times 6 is 30, and half of 30 is 15. So the area of the triangle is 15, and the height of the prism is 11. So now I have the area of the base, which is 15, times the height, which is 11. So 15 times 10 is 150. So another 15 would be 15 times 11. So that's 165. Okay, so I multiply these together, and it's 165. And this is feet again. Okay, so 65 feet. It's volume. It's 3 dimensions. I'm finding how much space the object takes up. So 3 dimensions, it gets a 3. Okay. So volume of a prism, I think, goes a little faster because you have the area of the base times the height. You identify what shape's the base. It's a triangle. So I need the area of a triangle formula times the height of the prism. Plug in all my numbers. All right. And then I got the area of the triangle and I got the height of the prism. Times those together, I have my volume. Okay. Wait, why are we multiplying by 11? A great question. I kind of answered it, but I'll go back and answer. Let me just catch up on some questions. I'm pretty sure I'm going to fail. No, you're not. You gotta have a little confidence. Okay. If you don't have any confidence, it's not going to go well no matter what you do. Why did you do the first problem times 1/3, but this one times 1/2? Okay, that's a great question, and this is actually a good time to ask it. All right, so when we're talking about volume, okay, volume of a prism is base times height. That's just the formula that we're given for any kind of prism. For a pyramid, it's 1/3 base times height. Okay, so these formulas are actually related. Okay, so let's say I had a square. Let's say I had a I'm getting a little, I don't want to get too sidetracked here, but a pyramid is 1/3 the volume of a prism if they were to have the same base. So that's where the 1/3 comes from. Is let's say I had a pyramid with this base, okay, I could do the same formula, base times height, but I would do it times 1/3 because a pyramid, because it tapers upward in all directions, actually only takes up 1/3 the space that a prism would of the same base. So that's why this is base times height. But for a pyramid, it's 1/3 base times height because a pyramid is 1/3 the volume of a prism with the same base. So the 1/2, this is an area of a triangle formula. Okay, so area of a triangle. Okay, and when I showed my students this, they were they were kind of like, what? That's crazy. I don't think they realized the connection here. So the area of a triangle, the formula for area is 1/2 times the base of the triangle times the height of the triangle. Okay, and the reason for this is let's say you had a square, or sorry, let's say you had a rectangle, okay? And let's say you have the length here and you have the width here, right? And this is what we were taught. I used to teach 4th grade math, so I know that you were taught the area of a rectangle is length times width. Okay, but we're going to rename these, okay? Because of the way that this is positioned, I'm going to call this the base of the rectangle, okay? And I'm going to call this the height of the rectangle, okay? So the rectangle is this high, this is its base, all right? And I can do the same thing with a parallelogram, okay? So here's a parallelogram, all right? There's the parallelogram, okay? Because parallelograms are quadrilaterals too, okay? They have a height, and they also, oh, sorry, it's a little slant there. Okay, here we go, okay? Parallelograms have a height, and they also have a base, okay? So parallelogram and rectangle, we find their area the same way, length times width, or in this case, base times height. Okay, that works for both of them, all right? So this is what people don't quite realize, is when you're finding the area of a triangle, okay, if I were to cut from corner to corner across the rectangle, okay, I would get a shape that you call a triangle, all right? And this would be 1/2 of the area of the rectangle. So if the rectangle is base times height, this is the rectangle, then a triangle with the same base and height would be 1/2 of that volume, so we times it by 1/2. Okay, same with the parallelogram. If I were to cut the parallelogram in half, the height of the triangle is still the same here, as you can see. Okay, so base times height equals the parallelogram, all right? But if I were to cut it in half, right, here's half of it. So that's a triangle. So for the triangle, 1/2 times the base times the height equals the triangle, okay? So, and it equals a triangle here. So that's where the 1/2 comes from in this formula. And I don't know if that confused you more or if that helped you understand it. So if it confused you more, but you know that this is the area of a triangle formula, stick with that. If this helped you make sense why it's this formula, then I'm glad I could help. But hopefully I didn't make matters worse, okay? So anytime you have the area of a triangle, you always use area equals 1/2 base times height, and this is why. That's the theory for the formula. So that confused me more. Okay, I shouldn't have done that. I apologize. All right. I don't know. I'm sorry about that. But that's, you asked the question, I answered it, I suppose. But whatever. If you want to go back and watch that one a couple times to see why, I wouldn't stop you. Okay. So I used 1/2 in this one because I have the area of a triangle. That's the area of the triangle formula. I used 1/3 because I was dealing with a pyramid. That's the formula. Okay. So let's move on to surface area before I make matters worse. So only square pyramids are divided by 3. Any pyramid. Pyramid formula for any general pyramid is 1/3. Oh man, I shouldn't have done that. I feel like that, like I think I just messed things up. Would you also stand up a pentagonal prism or hexagonal prism? Yes. Yeah, because again, the prism is defined by the name of its base. So if the base is a hexagon, it's a hexagonal prism. Okay. Again, prisms always have rectangles for sides, even rectangular prisms, and that gets a little bizarre, but I'll get to that in a second. Okay, let's finish up surface area on this problem before I make matters worse. Okay, so surface area, let's go ahead and unfold this. Okay, I'm gonna unfold this triangle, or this triangular prism. Okay, and again, this is making what we call a net. This is a net. So I've taken the prism. Okay, I've got 2 triangular bases. And these are congruent, so these are the same, okay? So I have 2 triangles. Now here's the thing. I have this side of the triangle is 6.5. Let me see if I can draw this a little bit. So I know that this side of the triangle is 6.5, right? So that means this rectangle right here, this edge is 6.5. I'm gonna write in a different color. So this edge is 6.5, okay? The length or the height is 11 for this rectangle, which means it's 11 here. And again, if this side of the triangle was 6.5, then this one is too from up here, right? These are both 6.5. Okay. So the rectangle is also 6.5. Okay, let me see. Now here's what's weird. If we're talking about this inside rectangle, okay, I have 11, but look at the base of the triangle. The base of the triangle is 5, which means that this line is actually different than the 6.5s. It's 5. Okay, so I actually have a different area of a rectangle here, and these two are actually the same because I have 11 times 6.5. So these are both going to be the same. And then I have 2 triangles that are going to be the same. So here's what's nice. I already found the area of the triangle right here when I did volume. I did the area of the base. It was a triangle. I plugged in the numbers, and I found that the area of the triangle is 15. So I'm actually just going to put that area right here. This one's 15, but also the top one is 15. So I already did the work. Okay, that's done. All right. So I need, when I'm doing surface area, I have to add up all the three-dimensional, or I have to add up all the two-dimensional figures area together, okay? So area of a triangle, there they are, okay? Both triangle 15, I found out the area of a triangle when I did volume. Okay, now you know the area of a rectangle because it's just length times width, okay? In this, or base times height, right? Either one, this side, so length times width, we'll just say. All right, so I'm gonna take 11, okay? Take 11 times 6.5, and my volume is going to be, or not my volume, my area. This is what happens when I teach when I'm tired. My area is going to be, anyone else quicker on the draw on that one, feel free to toss in the calculator. 71.5, okay, so the area is 71.5. All right, and this side is also 71.5 because they have the same dimensions, okay? Now the middle one, I have a length of 11, but the base is 5, right? So 5 times 11, all right, is going to give me 55 for this one, okay? So now I have the area of all 5 of the shapes that make up this 3D solid, okay? So I'm going to erase some of the numbers that give me that so we can just see clearly that these are the areas of each one, okay? So now all I'm going to do is add these together, okay? So 15 plus 15, that's 30. 71.5 plus 71.5, what's that, 143? Does that sound right? 143? I'm gonna double check my work just because I want to be right. Yep, 143. And then the middle one is 55. So I'm gonna add all 3 of these together. Okay, so 15 plus 15 got me 30. 71.5 plus 71.5 got me 143. And then there's my 55 right there. So I'm just gonna add these straight down. Okay, 9, 12, and I get 228. And again, this is feet, all right? And it's square feet because these are two-dimensional figures, okay? Surface area is squared, volume is cubed. All right, so where did I lose you? Happy to help any way I can, all right? So height does not matter when you are doing surface area. No, not in this case, no. Because we're just trying to find, I mean, the height of the triangle matters. I mean, that's the only time height matters. But again, I already did the work to get the volume, or sorry, to get the area of the triangle. So in this case, I'm just looking at 2 dimensions, length and width. All right. So in this case, for the triangles, I do have to do 1/2 base times the height of the triangle. But again, 1/2 times 6 times 5 got me 15, which I did over here. And I just put those as my area for the triangles because I already did the work. So now it's just a matter of finding the area of each of these rectangles, and I get that from the dimensions of the prism. I'm confused. You lost me. Okay, where did I lose you? Surface area. I don't understand this one. Okay. When you got 30, did you do 5 times 6? When I got 30 over here, I just added the area. And here's what I'll do. Let me do this. I'm going to do this another way. So all I did was I did 15 and 15. I did both of these. I added them together. Okay, and I got 30. That's where the 30 came from. Same with, I did 71.5 plus 71.5, and I got 143. Okay, so I just kind of added the numbers that were the same together because I could just times them by 2. It's the same idea. So let's talk about what surface area is. I guess I wasn't as prepared for this one as I wanted to be. So let me see if I can grab some construction paper, and hopefully my daughter doesn't mind. Stand by. Okay. Any other day, there's like 30 pairs of scissors in this house, and I can't find them. Okay. All right. So, all right, I'm back. Okay. Sorry, I'm so good. No, I'm glad. Hey, you know what? You're here getting help. All right. I'm happy you're here. If you're confused, you should be here. So please, I'm here to help you guys out. I know you're confused. I know this is all a confusing concept. So no apologies necessary, please. Okay. If anything, thank you for being here. Because if I had no viewers, this would be really boring. Okay. So, okay. I'm not really good at arts and crafts, so you're gonna have to bear with me. I'm gonna try to make a prism. Okay, here we go. I'm already failing. All right, let's see how this does. No judgments, please. All right, so I wish I had some music going right now to kind of like play me through my cutting out of a prism. Again, I wasn't as prepared as I thought I should have been. So in my class, I actually handed out some cutouts of these different shapes. So hopefully this helps a little bit. Okay. All right. So this is my attempt at a triangular prism. So bear with me. I did it kind of on the fly. It's not to scale, but at least it's blue, and I do like blue as a color. So there's that, I guess. Okay. Hold on. Stand by. Okay. Hold on. Okay. Hopefully that makes it a little better. All right. This is the effort I go through for my fans, right? Okay, so folding that. Sorry, hold on. Working on it. Okay. All right, so volume. And now I've got all the work done for both. We can talk a little bit deeper about this, okay? So what I was saying about finding the I'm sorry, everyone. Okay, here we go. Let's try that. Okay. So when I was talking about this with my students, what I had told them was volume is how much you can fit inside this object. Okay, so I have a 3D prism. Okay, so let's say it looks like an actual prism. Okay, it's folded up. I'm trying to figure out how much stuff fits in here. Okay, that's volume. That's how much it can hold. Okay, so let's say I had a really awesome aquarium shape this way. How much water could it hold is what I want to know. Okay, but if I'm building the aquarium and I want it all sealed up, I want to know how much glass does it take to make the aquarium. So to do that, I would have to cut the shapes of glass individually, right? Okay. And of course, I should have used like a rectangular prism, but that's okay. So like I was telling my students is, how much fits in the box is the volume, but how much cardboard do I need? That's surface area. Okay. So in this case, all I've done is unfolded the shape, and now I'm looking at the different two-dimensional shapes that are made when I fold this up. So I have 1, 2, 3 rectangles. I don't know if you can see. I think you can kind of see that. There we go. Sorry, my camera is actually like mirror image, so that doesn't help. I do things to the left and it goes to the right. So let me see if I can make it a little clearer. Okay, there we go. All right. So again, I actually have 3 rectangles. Okay, and they're different sizes. The two on the ends are the same, but the one in the middle is different, and that's what happened here. And then I have 2 triangles. Okay, so I have 5 shapes here, and surface area. I'm trying to find the area of each shape individually, and then add them all together to get the total surface area. Okay, so that's fine. I think that's the best way I can explain surface area. And it is a different calculation than volume, because again, volume, how much space does an object take up, or how much stuff can it hold? Surface area is, what objects do you need to make it? Okay, and two-dimensional. Okay, so again, when I lay this flat, piece of paper, it's flat. Okay, it's more or less two-dimensional. Okay, so that's why it's squared. Okay, 2 dimensions. You get a 2. All right. So hopefully that helped a little bit. I know I'm a fast talker too, so feel free to rewind this and watch it back. I'm getting through a fewer problems than I wanted to, and I know that this was part of the some people were coming to get some answers to the study guide. So I'll be understanding of that if we still had some issues on the study guide, and I will allow this to be watched tomorrow. So how did you get 143? I got 143 because this rectangle and this rectangle are both 71.5. Okay. Because from what I have here, so here, this rectangle is right here, okay? So when I unfolded it, this rectangle here is actually this one right here, okay? So I just laid it flat, okay? And I measured the length of it, which was 11, and I times it by the width of it, which is 6.5. So I got 71.5, okay? But on the other side of the prism, there's another rectangle that's identical to it. So really, I have 71.5 twice. I have 2 of them. Okay, so I have 71.5 and 71.5. If I add these together, 5 plus 5 gives me 10. 1, 2, 3. 7 plus 7 is 14. So both of these rectangles together end up equaling 143. Does that make sense? I messed up with the volume, so it threw me off and confused me highly. I see. Well, again, all the stuff's here, so if you have questions I can help you with, let me know. And I can stay on a little later too. I can let this go for a little while longer if you need me to. Let me see. Can we go over number 6, surface area? Okay, we can do that. I'm gonna jump to that one right now. I just gotta look at which one it is. It's on my phone. So let me see. 5 and okay. So this is actually good. 5 and 6 are very similar. So I'm just confused on 5 and 6. Okay. Do you remember how I told you we're gonna put up this golden formula one more time? Okay. the area of a triangle formula is going to come in handy. Okay, area for a triangle. Okay, remember the area for a triangle is 1/2 times the base of the triangle times the height of the triangle. Okay, so, okay, let's do this. There we go. We're going to color coordinate. All right, can I just erase all this? After that, can you do number 4? Yeah, I'll come back and do number 4. And actually, number 4 will go fast. Like I said, I think triangular prisms are actually the harder prisms, but rectangular and then anything larger than a rectangle, like a pentagon, hexagon, octagon, I think are actually easier. So we're gonna do, I'll do the hexagon, which is number 6, and pentagon actually works the same way, and I'll show you the difference. And then we'll go back to a rectangular prism, and you'll be so happy because rectangular prisms are way easier than the other prisms, okay? So, but this is important for any objects, any shapes that are larger than 4 sides, the triangle formula. Now, I know that's a weird thing to say because you're like, dude, a triangle has 3 sides. Like, what does that have to do with a 5-sided figure like a pentagon, or in this case, a hexagon? All right, this formula, commit it to memory, it's gonna be a lifesaver, okay? So 1/2 base times height, so the base of the triangle, okay, times the height of the triangle, okay? And this right here is the height, okay? So the reason I'm talking about this when we're talking about hexagons is you actually have everything I've shown you up here. You have actually all the knowledge you need in order to solve different types of prisms, okay? Now in 7th grade, you have a bit of a luxury, okay? You can assume that any pentagons, hexagons, octagons, nonagons, dodecagons, any kind of gon, okay, is larger. They're gonna have all their sides are gonna be the same, okay? So a pentagon or higher, we can assume in 7th grade, that all sides are going to be the same, okay? Mr. Coffee, so the volume for the triangular prism equals volume 1/2 base. Okay. I'll come back to that one. Chopsticks with 2 X's. I see your question, but I kind of went a different direction, so we'll have to come back to that one. All right, so I'll come back to that, I promise. Okay. So the shape in question on number 6, okay, is a hexagonal prism, okay? So I'm just going to talk about the hexagon right now. I love me a dodecahedron, man, let me tell you. But anyway, so we're going to talk about just the hexagon for right now, okay? It's a hexagonal prism, all right? So what I'm going to do is I'm going to draw the hexagonal prism over here, okay? But I really want to focus just on the area of the hexagon. Don't let the prism part scare you, okay? It's not too bad, all right? So a hexagon, on number 6, they do it on the bottom, but you could use the top if it's easier. It doesn't really matter. This is a funky looking hexagon. I apologize. That's weird looking. Okay. There we go. That's a little bit more hexagonal. Whatever. You get the point. So here's the information they give us. They go to the center of the hexagon and they draw basically from the middle of the side to the middle of the hexagon. Okay. They draw this little dotted line. And you're probably like, what is the point of that? They tell us this is 12. Okay. And then they go and tell us that the side over here is 13.8. And remember, we're allowed to assume in 7th grade that this is what we call an equilateral hexagon. Okay, that means all 6 sides are the same. Okay, so that means that if this is 13.8, so is this, right? So I'm just going to move that. Okay, I know the picture gives it to us on the side. I'm going to put it right there. Use your color coordination here. Does that look familiar? I'll give you a hint. It's right here. Triangle. How does this help us? Well, you gotta believe that there's a triangle there. Okay, if you believe hard enough, and actually mathematically speaking, there is a triangle here. It's right here. Ready? Boom, boom, right there. That's a triangle. Okay. Yeah, I know it's only one triangle. All right, but this is an equilateral hexagon. Okay, that means that every middle of this side to the middle of this side to the middle of the hexagon is always going to be 12. And then every side is 13.8. So what you're telling me, well, I guess what I'm telling myself, because I don't know, I mean, that's just the way it's going tonight, is that I can divide this into 6 equal triangles. So now there's not just one triangle. I count 6 triangles, and they're all the same. So there you go. So area of a triangle formula is great for objects that are larger than 4 sides because we're given the height, okay, we're given one side. So I can just turn that into a triangle, and then however many sides of the object I have is how many triangles I have. So in this case, I have 6 triangles. All right. So you multiply by 6. Game Beater 0303, you are a genius. And David Liv Sangan is a little skeptical with his but I respect that. So allow me to explain. So let's find the area of this hexagon. All right, area of the hexagon is the area of this triangle, 1/2 times the base, which is 13.8. I'll keep it blue. We'll keep it. What do you want, babe? Quit barking at me. Oh, it's Ari. Okay, so 13.8, base of this triangle I made, times the height of this triangle. And because there are 6 equal triangles, okay, I'm hoping the green shows up. Okay, I'm going to times this formula by 6. And that altogether is going to get me the area of the hexagon. Okay, so mine is a bit glitchy. Is it just me? It might be. I have full Wi-Fi strength, and I've got good. Apparently, the stream is going pretty smooth from what I'm seeing. So, all right. So now that things are going to get a little more intimidating, we're going to bring something in to lower the intimidation. Okay, so give me 1 second. All right. So it is clinically proven that puppies reduce stress. Okay, so that you're not stressed, we're going to bring a puppy into this part of the problem. Okay, so don't let the hexagon scare you. Okay, just calm. It's a calming puppy. Okay, puppy's going to keep you calm. Okay, right? All right, perfect. All right, so you can help her. Right. Useless. All right, so now if I multiply, you're just going to leave. You're just going to leave these people hanging. Don't eat the scraps on. Get out of here. All right, sorry, useless. That's Ari. All right, so hopefully the puppy has calmed you down. Now let's get back to work. All right, so now I'm going to find the area of this hexagon, which again is the area of this triangle times 6 because all these triangles are the same. Okay, so let's get out our calculator. Let's do some calculations because that's what calculators do. Okay, I thought I had a clear button. I guess I do. All right, so we're going to do 1/2 times 13.8, which is the base of the triangle, times 12, which is the height of the triangle. All right, and one of these triangles, okay, so one of these triangles, the area is 82.8. All right, so that means every single one of these little triangles is 82.8. Okay, this one's 82.8. This one is 82.8. This one is 82.8. This one, believe it or not, is 82.8. And you guessed it. I know you wouldn't believe it, but this one is also 82.8. Crazy, right? So I have 6 of the same triangle. So I'm just going to take the area times it by 6. Times it by 6. And the area of the hexagon, and this is just the area of the hexagon, is 496.8. Okay, and I don't know what my unit is. If you have your paper, let me know what unit that is, and I'll tack it on there. But whatever it is, okay, well, actually, we don't even exactly need it right now. So all I got out of that was the area of the hexagon, okay? So all you need to tell yourself is, okay, if you turn these bigger shapes into triangles, okay, you just use the area of the triangle formula and times it by the number of sides the shape has, okay? So not too bad, all right? So now I know the area of the hexagon, okay? So now let's start talking about surface area and volume, okay? Don't freak out, all right? So volume equals the area of the base times the height of the prism, okay? Now I told you what the area of the base is, okay? I showed you the formula for that. So that's what you would put in place of B, which in this case would be this answer, okay? So volume equals the area of the base of the hexagon, which is 496.8. So this hexagon is 496.8. Is it centimeters? Okay, so that's centimeters. All right. So this would be centimeters squared because it's a flat object. All right. Hey, Mr. Coffee. Nice way to be spending your life. Yep, you're telling me. It's what I do. And seeing as that's your real name, just be careful what you're saying on here because, again, this can be used for disciplinary stuff, and I know you're an 8th grader, so, just be careful, my friend. Stopping in there. That's pretty cool. And I appreciate the comment on my coaching. So anyway, so the base of the prism is 496.8, and I'm timesing it by the height of the prism, which says it's 20, which is these rectangular sides here. Okay, so times 20. Okay, so all I have to do is times the area of the base times the height, and I'll have the volume of the hexagonal prism. And again, it's centimeters, so it's going to be centimeters cubed because it's volume. All right, so 496 times 20 gives me a rather large number. It gives me 9,936 centimeters cubed. Okay. So let me see what I'm doing here. Okay, so yeah, so I've got the volume, and again, the area of the base was what took the most. But once I have the area of the base, I just times it by the height of the prism, and I got my volume. Okay. So the next part we're going to talk about is how to find the surface area. And believe it or not, surface area for these bigger shapes is actually a little easier because every single rectangle, since all these sides are the same, they're all 13.8 all the way around, the rectangles are actually all the same area as well, which makes things way easier. Okay, so I have the area of the base right here. So this is the base, right? So if we're talking about the area of a rectangle, okay, the side of the triangle was 13.8, okay, and the height is 20, so I would just do 13.8 times 20, okay? So I'm just, again, finding the area of one of these rectangles, okay? So 13.8 times 20 equal, so the area of just one of these rectangles is 276, all right? Now here's what you have to realize is since it's a prism, I have a hexagonal base on top and on the bottom, okay? So I have two hexagonal bases, okay? And I'm gonna add these to 6 rectangles, okay? And like I said, I like to just draw this out for myself. I feel like that kind of helps me. So now what I'm gonna do is I know the area of the hexagon because I got it during volume, right? And we did all that work up here. So I'm just gonna plug this number in. The area of the base is right here, okay? So 2 times 496.8, and we're gonna add that to 6 rectangles, and we just found the area of those. We did the length times the width, okay? Because the length of the hexagon was 13.8, so that's there. And the height of the prism was 20, so 13.8 times 20 gave me that one rectangle. And I have 6 of them, so 276. So now all I have to do is times, I just have to multiply these two together, okay? So this is 1656, okay? And I'm gonna add that to 496.8 times 2, all right? So hold on. 496.8 times 2 equals 993.6, okay? So now I'm just gonna add these two together, okay? Because this is the area of the bases, this is the area of the rectangular sides. I'm just gonna put it all together, okay? So 1656, all right? So my total surface area, all right, and this is all surface area, surface area, surface area, surface area, surface area, okay? And that equals 2,649.6, and that's centimeters squared because I'm dealing with 2-dimensional shapes, okay? So, and Mr. Miles, I'm glad this helps a lot. I'm probs a stranger, whatever, it's a public stream. Okay, so yeah, like I said, I can see who you guys are, and every time I start a stream, I always tell you guys, be careful, because, you know, I don't want this to have to come back to you in a disciplinary way. So I'm glad that everyone's behaving and everyone's on task, so I do appreciate that. So I know I went through a lot here, but again, you can always watch the stream again. All right, you can always go back, rewind, watch it over again, and until you understand it. Okay, so I'm getting close to the hour mark, but what I'm willing to do is I'm willing to keep going. Okay, if you want to ask questions about this one, I'll hang on this one for about another 2 minutes. I see someone said they did something wrong, so maybe we can try to figure out what that is. And then I'm going to move on. I see that Emma has asked about number 7, so I'm going to go ahead and go over number 7 as well. Number 5 is the same exact thing, but it's a pentagon, okay? So with a pentagon, all you would do is the same thing we did here. They give you this distance. I think it's like 4, and this is 5. Okay, it's a pentagon, so I just cut it into 5 triangles, all right? So this would be area of the triangle, 1/2 times the base times the height, and I have a 5-sided figure, so I would times it by 5, okay? And then you would do all the same things you do with the hexagon. So a pentagonal prism is going to be the same thing, which is number 5. So I would encourage you to use number 6 and try to use the same strategy for solving number 5, which is a pentagon, okay? Because the same rules still apply, okay? What about number 9? We can do that. Can you go over number 4, surface area? I can't figure out what I did here. Okay. Well, again, I would encourage you to just watch the stream again and kind of see the steps I took, look at the steps you took, and then see what didn't match up. I know I did say I was going to do number 4, so I do need to go back and do that. That one's going to go pretty quick, and then I know someone asked about number 7, and we'll kind of see where we're at with time because I want to make sure that, I don't want the stream to look like – I don't want the stream to take forever and have people having a hard time navigating it. So, all right. So number 4, I'm going to go back to my rectangular prisms are awesome. Oh, my gosh. I love rectangular prisms. They're so easy. Well, they're so much easier, I should say. None of this is really easy. But if I had to pick an object, I would put the same measurements. So I have 25, 20, and then the height is 4. Okay. So I have these 3 measurements. Okay. I promise you this is so much better. Okay. Rectangular prisms are nice. Okay. So I have 3 faces I can see. I have 3 rectangles. I have 1, I have 2, I have 3. Okay. So 3 rectangles I can see, but I know in a rectangular prism that there's one on the bottom that I can't see, and it's the same as the top. All right. There's this one in the front. There's another one in the back I can't see, but they're the same. Okay. This one on the right, there's one on the left, and they're exactly the same. Okay. So I'm going to talk about these 3 rectangles, and I'll tell you what we're going to do with what I just mentioned. Okay. So for volume, this is going to make you very happy, I promise. Okay. So volume equals the area of the base times the height. Okay. Now with a rectangle, it's a rectangular prism. And I know that I said that the name of the 3D solid defines what the base is. Okay, but this is a rectangular prism. And that means that all of its sides are rectangles. That means that any side could be the base. That's confusing until you realize that no matter which way I start, no matter what I call the base, I'm going to get the same answer. And for a rectangular prism, I'm just going to use the bottom rectangle, which is the same as the top. I'm going to use the bottom rectangle as my base, okay? So I've identified the base. It's a rectangle. How do you find the area of a rectangle? Well, the area of a rectangle is length times width, right? And we're going to times that by the height of the prism, okay? This is interesting because I'm only given a length and a width and a height. So the volume of a rectangular prism is length times width times height. So for a rectangular prism, to find the volume, all I do is multiply these 3 numbers together. All right, so 20. Oh man, all right. I feel like I could do this in my head, but why? It's too late. I've been doing math all day. 25 times 20 times 4 is 2,000. Okay, so the volume is 2,000, and what's the units? 2,000 centimeters. And it's cubed because this is a perfect example of what I mean. It's a 3-dimensional figure. I have 3 dimensions. I have length, I have width, I have height. 3 dimensions, we get a 3 on the unit, okay? What I'm trying, okay. Rectangular prism's way easier. Yes, I agree, okay? And let's try to keep our chat on task. I know it's been a long stream, okay? So now let's talk about surface area, okay? So let's just talk about each of these rectangles. And again, this one will go fast, and then I'll get to number 7, and then I think we're going to call it a night on that. All right, so each of these rectangles, okay, I'm going to find the length and width of each rectangle, okay? So if the height is 4 here, it's also 4 here, and it's also 4 here, okay? So I now have the length and width of this rectangle. I have the length and width of this rectangle, okay? Now I know that the rectangle on the bottom is 25 by 20, and that's the same as this rectangle on top here, which is 25 times 20, okay? So all I'm going to do for surface area of a rectangular prism is I'm going to find the area of each rectangle that I can see. Okay, so I can see the front one. So 4 times 25 is 100. Okay, so I just multiply these 2 numbers together. Length times width gives me the area of the rectangle. Okay, same over here. Length of the rectangle times the width. 4 times 20, that's 80. Okay, and then 25 times 20, let me see, 25 times 2, 50, so it's 500. All right, so this is the area of the 3 rectangles that I can see. Now keep in mind, okay, that there is a rectangle on the bottom that we cannot see, okay? But it's the same as the one on top. So I actually have another 500 on the bottom, okay? I have 80 on the right. So on this side, I have one that I can't see that's also 80. And hopefully you can see that. Yes, you can. Try to draw it right a little darker. 80. There we go. 8. That's an 80, I promise. Okay? And then you have one in front that's 100, but there's one in back you can't see across from it, and that one is 100, okay? So what we're saying here is that I have 2 of each of these rectangles, right? I have two 500s, I have two 100s, and I have an 80. So what you can do with the surface area of a rectangle, okay, or surface area of a rectangular prism, okay, is I can add 500 plus 100 plus 80, all right? I can take all three of these rectangles and I can times them by 2 because I have 2 of each of them. So I can add these together, times it by 2, okay? So surface area is going to equal 500 plus 100 plus 80. So 500 plus 100 is 600, plus 80 is 680. All right, and I'm going to times that by 2 because, again, I have 2 of each rectangle. Oh, let me see. So what's that? Surface area, is that equal? What is that, 1,360? Did I do that right in my head? I get tired this time during the stream, so let me see. 2 times 680. Yep, 1360. So he goes 1,360. It's centimeters, and I'm talking about the two-dimensional rectangles, so 2 over the centimeters. Hi, helpful tips. Okay, cool. I need help on number 9. All right, I want food too. And actually, I had a little food. This is not an advertisement for McDonald's, but anyone who's in my class knows I love Dr. Pepper. So that's the way to my heart. You ever want to repay me, or for all the streaming I do here? Throw some Dr. Pepper my way. I'll be a happy man. I'm just kidding. Don't do that. Okay. Anyway, so I found the surface area and I found the volume. You can see there's a lot less steps because a rectangular prism is just a little bit easier to work with. So again, you can go back and you can watch these again to see how to do a rectangular prism. Okay. So, okay. I got a little time. I'm going to keep going. All right. I'm going to power through just because I like you guys. All right. So what's nice too is if you know someone who hasn't watched the stream live, or maybe you stopped watching it for a little while, or maybe you hopped in late, when the video uploads, you could just look at what shape I'm going over. You can skim the video and just go to the shape that you need. So someone said number 7. Let me scroll on number 7. What does number 7 look like? Oh, yeah. Oh, my gosh. We didn't even touch composite figures. Whew. Okay. So this is a doozy. All right. So we have a cube on top of a rectangle. Well, we have 2 rectangular prisms stacked on top of each other. All right. So, all right, here we go. Man, I'm tired. Okay, there we go. All right. So I know that the drawing is drawn one way, okay? And I'm going to draw this a little differently, okay? Here we go. Hats off for my artistic abilities here. I mean, I can't hear anyone else complimenting me, so I got to compliment myself, okay? Keep up the good work. Oh, my gosh, thank you, helpful tips. That was a really helpful tip. That's what I needed. That was like just the amount of positive energy I needed to just keep this stream going. So I appreciate that. All right. So you'll notice that I drew this as one solid piece. Okay. The reason I did that was when we talk about volume. Okay. Volume. What we're going to do is we're going to separate the 2 shapes. Okay. We're going to talk about volume. Okay. We're going to talk about shape 1 and shape 2. Okay. So we're going to find the volume of 2 separate shapes, add them together. And that's not bad, okay? Surface area is where this gets a little tricky, okay? Because surface area talks about what I can see versus what I can't see, okay? So surface area gets a little bit trickier, okay? So the reason I'm talking about this is now that I've put these 2 on top of each other, there's a bottom of this cuboid that I can't see, and there's a part of this rectangular prism now that I can't see, so I can't count that as surface area because it's no longer on the surface, okay? If you were going to measure the exterior of my house, you can't measure where the roof meets the actual house because it's on the inside, okay? It's not on the surface, okay? So where these objects come together, I'm not going to be able to count that in my surface area. So this is where things get a little tricky. So you got to bear with me here, okay? Lots going on, all right? So now I'm going to draw this more like it is on your problem there, okay? So you can see you've got a cube. Can I do this in a different color? Is that cool with everybody? Is that cool with everybody? Of course it's cool with everybody. All right, thanks. Thanks, guys. Thanks for the affirmation. Okay, so I'm going to do the inside here. I'm going to do the inside on this one. Here we go. Hopefully that looks okay. Okay, you can see I kind of missed there, so we'll just bring that back down. All right, not bad, not great, not my best work, but with the way modern art is these days, I probably could sell it for millions. Okay, so This is my best. This is the best I can do, people. Okay. So let's talk about volume first. I have two shapes, and here are the measurements I am given. Okay. I'm going to do shape number 1 in purple, and shape number 2 I'll come back to. Okay. So, So I'm given 4 for the width. I'm given 4 for the height. And I'm not given anything for the depth. Okay. So I don't have a dimension here. But I see that they line up together on this line. Okay. So if I know what this, so we're going to use properties of a rectangle, right? So if I can figure out the way I would figure out this is it's a rectangle. Okay. So whatever this is, it's going to be the same as the side across from it. But of course, they don't give you this one, right? So I'm going to follow the trail here. Okay. Hang with me. Hang tight. I'm going to fix this too while I'm at it. Okay. There we go. That's a little bit more like it. This one too. It's a little bizarre looking. I'm going to fix this. Sorry, I'm a bit of a perfectionist, apparently. Okay. So again, I don't know this one. So I'm going to go to this one, see if it's across. Oh, no, it's not. Great. But luckily, if I don't know this one, I can look across from here, and these have to be the same because it's a rectangle. So if only it would give me this measurement. Oh, thank goodness it does. It's 6. Okay. So if this is 6, then this is 6 because it's a rectangle. If this is 6, then that's 6 because guess what? It's a rectangle. So now I do have all 3 dimensions of this cube. Thank goodness. Sponsored by McDonald's. I should turn the arch out. There we go. They better pay me for this. Throw an ad my way. I'm just kidding. Don't do that. Okay. So anyway, now I have all 3 dimensions of this top one. All right. And now I got to start figuring out the dimensions for the rest of them. Okay. So the length of this side is 10. Oh wait, I said that I would do this in blue. All right. So let's do it in blue. So it's a 6. So the depth is 6. The length is 10. And the height is 4. Okay, so I have all 3 dimensions of both figures. Okay, this one I had to work for. So again, if you need to go back and figure out where that number came from, again, rewind the stream when the video saves, and then it'll show you how I got that one and what my reasoning was. Okay, on to the main event. Okay, so now that I have all the measurements for both figures, I can start to find their volume. Okay. So we know that volume equals base times height. Okay. And I'm talking about object 1 for right now here. So we're going to call this 1 and we're going to call this 2. Okay. So 2 and 1. So you know where all these things are coming from. Okay. So we're going to do a surface area of 1 and we're going to do a surface area of 2. Okay. All right. So this is going to be a lot, but this is my last problem of the night. Okay. I'm going to call it after this. Yeah. Oh my gosh. Without Kylie's art easel and her, alphabet sorting tubes for reading, we would be nowhere. All right, and if we're being honest, okay, we gotta give a shout out to Mason, okay, because you're sitting on a box of diapers, okay. So I guess this is also a thanks to Mason for letting us borrow his box of diapers. So there you go. But anyway, back to work. So the cube, I'm gonna find the volume of the cube, and now we know that that rectangular prisms are very easy to work with comparatively, so that helps. So now we know that we could do volume of the rectangular prism as length times width times height. So all I'm going to do is multiply all 3 numbers together. Okay. So 4 times 4 times 6. And once I do that, I will have my volume, which 4 times 4 is 16 times 6. Was that 96? Does that sound right? Okay. And I'm not going to worry about units for now. I'll come back to units at the end when I'm all done. Okay. Pampers. What are you talking about, man? These are Loves. Okay, that's a great brand. But anyway. All right, so now I found the volume of this cube, or this rectangular prism. I'm just going to double check my work because, like I said, I get tired and I start to make mistakes. So 16 times 6, I think it is 96. Yes, okay, it is. All right, I feel better. All right, so I have a volume of one object. All right, it's 96. Okay, now I got to find the volume of the other rectangular prism. Okay, no apology necessary. I understand. Simple, easy mistake. All right, so what I'm going to do is I'm going to multiply, again, volume of a prism is base times height. All right, so, but I'm going to change this to length times width times height because the base is a rectangle, so length times width is the area of the base. All right, and I'm moving it over because there's a smudge of glue here and I can't get rid of it. Okay, so I'm going to plug in the length, which is 10, the width, which is 6, and the height, which is 4. Okay, so I have 60 times 4, which is just 6 times 4, 24 plus a 0. So my volume here is actually 240, okay? So now I have the volume of both objects, okay? I have 240 and I have 96. So now to find their total volume, I add their volumes together, okay? So it's not that bad, okay? I'm just doing the volume formula twice on two objects that are stacked, okay? So 6 plus 0 is 6. 9 plus 4 is 13. I carry the 1. 1 plus 2 is 3. So this is their total volume. Okay, the volume of both objects together is 396. The unit is centimeters. Okay, and they're three-dimensional figures. We're finding out how much space they take up, so it's centimeters cubed. Okay, and hopefully you can see that. Okay, stop. You're not a mistake. Oh my God. Okay, we're getting a little deep here. Let's not go that direction. I was just saying that I make mistakes this time of night, so don't take my words out of context. All right, so now we're gonna talk about surface area. Okay, I'm still gonna talk about object 1, and then I'm gonna talk about object 2. Okay, so if I were to unfold this cube, okay, and this is where kind of got to draw yourself a roadmap here. I know you were joking, I know, but I got to keep us on topic, just like I would in class. So. So let's unfold the rectangular prism, okay? We're gonna unfold it. All right, there we go. All right, so I have a 4 by 4 by 6, okay? So I have to think about how I'm gonna draw this, okay? So I'm gonna call this is gonna be the base of the cube, okay? So this would be 6. Hold on, let me make sure I do this right. This would be 4. So this is 6. Then this is 6. Okay. So now I'm just kind of drawing myself a map here. Okay, so those are 6. This is 4. So this is 4. This is 4. This is 4. A lot of 4s. Okay. This is 4. All right. So this is kind of the hard part. Is just kind of figuring out where everything is. It's a little harder with this one because I have 2 4s. So I think that's kind of harder to draw. Okay. So now here's the thing. I have a 6 by 4, because again, if this is 4, this is 4, so this is 4. So this one, this 6 by 4, I can't see that. It's underneath for surface area. It's on top of the object. So again, if this line wasn't here, I wouldn't be able to see that. So I can't count this rectangle, this 6 times 4, in my surface area. Okay. So I have one rectangle that I'm not even gonna draw. I don't even know why I drew that. I feel like that just made things worse. Can I start over? Can I get a mulligan on this one? I'm gonna start over. Okay, so I'm just gonna look at the dimensions, just like I did earlier with the rectangular prism. Let's just talk about the ones I can see. Okay, so I can see that on top I have a 4 by 6, because if this is 6, so is this. So I have a 4 by 6 rectangle. Okay, and I know, so 4 times 6 is 24. Okay, and I know I'm gonna have 2 of those. Okay, because if I have one on top, I have one on the bottom. Okay, and I'll talk about that in a second. So I have one I can see here, okay, which is 6 by 4 again. Hold on, let me see. 6 by 4. 6 by 4. Yeah. Okay. So I'm going to do that again. 6 times 4 is 24. Okay. I have 2 of those as well. And then I have 2 4 by 4 rectangles. So if this is 4, so is this. If this is 4, so is this. So 4 times 4 is 16. So I have 2 rectangles that are 16. Okay, now here's the tough part. This is what I've been saying. I have one 6 by 4 rectangle I can't see because it's on the bottom. And I know 6 times 4 is 24. Okay, I have 2 of those. Okay, but there's one I can't see. So I'm actually not going to times one of these by 2 because I can't see the other one. Okay, so realistically speaking, I have 24 and I have 2 24s. So really I have 3 times 24. All right, plus 2 times 16. So there's only 5 sides of the cube I can see. So those are the only ones I can count, okay? So what I'm gonna do is 24 times 3, which is 72. Okay, and I'm gonna add that to 16 times 2 is 32. So I'm just gonna add 32. Okay, so 32, and I get 104 centimeters squared for just the top cube, okay? So now let's talk about the bottom one. Okay, this one's I feel like this one's a little easier because I don't have, all the dimensions are different. Okay, so I have a 10 by 6 rectangle on the bottom. Okay, 10 by 6, so that's 60. And remember, if I have one on the bottom, I have one on the top. Okay, so I have 2 of these. All right, I'm going to add that to my 4x6 rectangle. Okay, and 4 times 6 is 24. All right, so then I have two of those. And then I have a 4. Remember, the height over here is 4. So the height over here is 4. So the height over here is 4. So now I'm talking about this front rectangle. 4 times 10 is 40. Okay, so that one's a little easier to get. Okay, but there's something funky that's going to happen here. So hang on to what's going on here, okay? So I'm going to multiply each of these by 2. So 120 plus 48 plus 80, okay? And once I add these together, which I'm just going to do with the calculator to save time, okay? So 120 plus 48 plus 80 equals 248, okay? And again, I know I've been going kind of slow, all right? So I know you're probably like, oh my gosh, how am I going to finish all the composite problems on the test? I promise you, it won't take you as long, and there's only one problem on the test that's composite like this. Mr. Coffee, I might be wrong, but I don't think that the volume for the smaller cube's volume is 96. Isn't it 64? 4 times 4 is 16 times 6. Let me see. Maybe I might have done something wrong. Like I said, I'm getting kind of tired, so this is when I start to make mistakes. I will double check. Okay. So I have a 4 by 4 by 6. So I would do 4 times 6, which is, 4 times 4, which is 16, times 6 is 96. So it would be 96 as far as I know. Do I look tired? Do I start to sound tired? So I would say it's 96. If it's 64, let me know why I think you're thinking it's a cube, because 4 times 4 times 4 would be 64. Okay. But I have 4 times 4 times 6, because remember, this was 6. So this is 6. So actually that's 6. So it looks like a cube, but it's actually not. So that's probably what happened. You're not a fail. I understand. Trust me, I'm probably making mistakes too. So anyway, so now I have the surface area of both. But here's the thing. I did the surface area of this rectangular prism as if I can see all of it. But remember, there is a 4 by 6 section of it I can't see. 4 times 6 is 24. So this is weird. But I actually have to take away 24 square centimeters, okay, because I can't see it. So really, I only have 224, okay? I know it's a little weird. I know it's kind of hard to think about, but I have to take that away. I can't see it, all right? It's buried underneath, all right? So that's something you'll have to keep in mind when you're doing the composite problem. So now to find the total surface area, okay? Total surface area is going to be both of these combined, okay? And I've already accounted for what I can't see on this one, and I accounted for what I can't see on that one. So now all I have to do is add the numbers together. So 224, which came from here, okay, plus 104. All right, and I'm going to just add these together in purple so you can see it. So 4 plus 4 is 8. 2 plus 0 is 2. 2 plus 1 is 3. Okay, and it's surface area, so it's centimeters squared. All right, I know I went through a lot with that problem. Okay, and I know I said I'd stick around. So I may as well just make it an even hour and a half because there was a lot to cover tonight. I know, I'm sorry. This is just what happens. I mean, I've been doing math all day. Yeah, I come home and then I was with my kids all evening. So they run me down a little bit. Put them to bed, had a little surge of energy. And then, by this time I'm just, this is like me being at the board for 80 minutes straight. So it is a little tiring. So thank you for sticking with me on this one. But hopefully this is helpful. And hopefully you can kind of scrub through the video and find where you want to watch each shape and how it works. So, well, yeah, I know, I'm drinking the Dr. Pepper. I should have brewed some coffee for, it probably would have been more aesthetically pleasing on the video because I am Mr. Coffee. So I'm confident for this test. Good. I want you to be. You need that rest to teach tomorrow. Oh yeah, after this, I'm going to bed. I was gonna watch Doctor Strange because I got to get caught up for Endgame. I haven't seen Doctor Strange the movie in a while. So, but I'm looking at the clock. That ain't happening. So, but why make these if you're tired? You better be getting paid for the ad. I don't get paid for this. No. All right. If we're being honest about it, no, I do this. I volunteer my time to do this part. Because my wife works the night shift, my kids are in bed, so I'm just hanging out anyway. So I'm more than happy to do this for you guys. And again, my thing is I really want you to understand that we as teachers, I know sometimes it feels like we're against you, and I tell my classes all the time. I know it feels like it's like you versus us, but it's actually we want you to do well. We really do, and we provide you with as many opportunities as we can to have you do well. Okay. And so the people that are watching this video, you're taking advantage of this opportunity. And so I'm more than willing to provide it if it's going to help you do well on a test and help you feel confident that you understand the material, okay? Because, I mean, not every kid can get it in a 50-minute class period. There's nothing wrong with that. You all have strengths. You all have things that you need to work on. For me, math was a strength of mine. Writing was somewhat of a strength, but my reading needed some work. So, for me, for math class, that might be the one you fear. For me, it was reading class. Like, I just couldn't keep up with the readings the way other people did too. So, so keep that in mind. If you have to get a little extra help, there's nothing wrong with that. That's what this is for. Okay. So if this helps, I saw 30 people on tonight. So if this helped 30 people, that's great. If 30 more people watch it tomorrow, then that's 60 people that we were able to help. So it's totally worth my time. Okay. And like I said, I'm just hanging out anyway. So hopefully this was helpful. And if you have any other questions about composite figures while I'm hanging around, I don't mind answering some questions. I see someone asked about number 9. I'll see what number 9 looks like. Okay. Oh, this is one that doesn't give you a picture. Okay. So this one, the best thing I can tell you for this one is to draw the figure. Okay. So what I'm going to do for you, because I've only got about 4 minutes left that I'm going to use here. I'm going to go ahead and just show you how to draw this figure. And then I'm going to encourage you to find the volume of the prism. Does it ask for both? It just asks for the volume. So once I give you the dimensions, I'm going to encourage you to find the volume on your own here. Okay. So I can do that. I said I have 4 minutes. I'm going to use the 4 minutes. Okay. Thank you so much for that. I'm happy to do it. I'm really glad you guys were able to tune in. And if you're coming from a different team, that's awesome. I don't get to teach you guys. So I'm very excited that that I was able to share this with 7 Red and 7 Blue as well. So, and again, your teachers, whoever your teacher is, they know the same information I do. I'm just finding another way to share it out, and I'm happy to share that with them. So any questions from this, you can always ask them as well. So, and again, I show things a little differently. So they might have a different way to show it that makes it easier than I am. So the base of the right prism is a right triangle. All right, so I just heard a right triangle. I'm drawing a right triangle right away, okay? So I'm drawing a right triangle, okay? And they said the base of a right prism is a right triangle. Okay, so I have a triangular prism, all right? So I'm just going to draw. I drew this so weird. Okay, how do I want to do this? I guess I could do it that way. That's fine. All right, sorry that's drawn sideways, but I guess I got a little ahead of myself. Okay, so I have a right rectangular prism, I guess. Okay, so with legs, okay, so the right triangle has legs of 3 and 4, okay? And if the volume of the prism is 36 cubic centimeters, find the height of the prism. Okay. So they're telling me that the volume of the prism is 36. Okay, so this is actually one we have to work backwards. I didn't talk about these tonight, so I guess I should do that. Okay, so the volume of the prism, so it's volume of the prism, right? So volume equals base times height. This is the formula I'm working with, okay? And they don't give me the height, okay? They don't give me the height, but they, all right, I got to figure out how I want to say this so I don't confuse you. So they don't give me the height, but they give me the volume, okay? And so the volume, if the volume of the prism is 36, so the volume is 36, okay? I still haven't found the area of the base, and I don't have the height, so I know that I don't have the height, but I can find the area of the base, okay? So the area of the base, okay, it's a triangle, okay? And a triangle is defined, its area is 1/2 times base of the triangle times the height of the triangle. Well, it's a right triangle, so that's the base, and that's the height, okay? So I can plug those into the equation, 1/2 base times height. All right, so 1/2 times 12. All right, so half of 12 is 6. Okay, so now I have the area of the triangle. All right, area of the triangle, I'm going to color code this. Area of the triangle is 6, all right, because it's 1/2 base times height. So now I'm going to plug 6 into here because now I have it. All right, so this right here, this is just your run-of-the-mill equation. So if you remember when we did equations, we did inequalities. Okay, don't just look at this as 6 times h. Look at it as 6h. All right, so if you're multiplying by a variable, okay, how do you get the variable by itself? So now we're going back to when we did equations, right? That's the same as saying 6x equals 36, all right? Well, if I'm timesing x by 6, how do I get rid of multiplication? I divide by 6. And what I do to one side, I do to the other to get the variable by itself, right? So x is going to equal whatever 36 divided by 6 is. Okay, so in this case, we're just talking about h. We're talking about the height. We're talking about h right here, okay? So same thing. I have 6 attached to an H, just like I would to an X, right? So how do I get 6? How do I get rid of the 6? I'm timesing by it, so I got to do the opposite. I divide by it. Boom, it's gone. What I do to one side, I do to the other. Okay, so 36 divided by 6 is 6, which equals H, which means the height of the prism is 6 as well. All right, so whoa. So in this case, when you're given the volume, you have to work backwards and you have to figure out what you know and what you don't know. So if you're given a problem that doesn't have a picture, draw a picture of what it is. Okay, plug in the values you have, and then try to figure out using the formula. So in this case, it was a prism, so I used the prism formula. Okay, I plugged in what I knew I had. I was given the volume. I wasn't given the base or the height, but I was given the numbers to figure out the area of the base. That's where the 6 came from. Okay, so now it just became a multiplication problem. 6H equals 36. Okay, so hopefully that helps. I probably should talk about that earlier, but there are 1 or 2 problems on your test where you'll have to actually undo the formula. So you'll be given the volume and you'll have to work backwards. So, oh my God, I have to do running of the champions tomorrow. Oh, good. Thank you so much for your help. You're welcome. Glad to do it. I must have missed a bunch of comments, so I'll have to go back later. So I don't want to because I know. Oh, you'll be fine. Just stay on your feet. Okay, so it sounds like our time. It looks like our time's up. I think this is about 90 minutes is about all I can do. So if you have any other questions, again, you can always scrub through the video, go back and forth, and figure out which objects you want to see again. You can always ask your teachers questions, and our test is going to be on Friday, at least in my class, and I think the other classes as well. So you still have tomorrow. So if this created more questions, bring those questions with you to class tomorrow. And if you're in my class, take advantage of my small group in the back of the room. Come join that group if you had a question on something specific, or if you have questions on the problems tomorrow, and I can help you out. So you're very welcome. Glad to do it. Thank you for tuning in. And if you're in my class, I'll see you tomorrow. If not, say hello to me in the hallways. All right. Have a good night, guys. Hopefully that was helpful. And I have a mouse down here, so I'll use that. Later. See ya. Bye-bye. And yes, I want to end it. All right. Now I'll say goodbye. It's that awkward, third goodbye. Later.